the tea tastes.
What are we getting for tea?
Huh?
What are you making?
I don't know. Are we doing
I've
the
seen
group
it
one
enough.
or
I
the
didn't watch
individual
this.
ones?
I don't care.
I
Okay.
watched it too. I watched it 3.
Mine's,
Never
oh, I
mind, I
guess
don't need to watch it.
I didn't.
Aliens here.
Ooh.
There's no one better than that.
I know, it's really sad.
This looks pretty good.
What's this in here?
I'm just gonna cut these high. Oh wait,
Are you guys ready?
Yeah, because I only want this.
there it is.
I love Dreamer. Griffin, who'd you go for the last election?
Oh, yeah.
Obviously the Green Party.
I did Trump. Oh, I saw the Green Party. I'm like, what?
Why would you not?
Dude, I did the socialism. I saw that, but I'm like,
That's the Green
Came
Party.
in for the
I'm like,
last
nah.
election, the Green Party candidate said that Wi-Fi causes cancer.
Oh,
That's when you know.
That's when you know they're
I voted for,
Wi-Fi.
for the Senate, I voted for Wilbur Wilson.
I almost
Because he
did
was
that.
his own party.
I almost did that. Because his party was Wilbur Wilson.
Yeah, he was his own party. I thought that was amazing.
Like if
Oh, I
your
think I-
party named after you, you're doing something
Right, and also it was so cool because he like cut the vowels for the name. It was like Wilbur Wilson. But like,
You're like, that is amazing.
like WLLSN.
That's
I love it. Okay, I'm ready.
So
Are we,
I
wait,
don't do it on there.
You want to write these down, probably.
right, okay.
Huh?
What is this?
Like notes.
Wait, you guys taking government next semester, right? Yeah.
I'm
Nice. Wait, you're not taking government? Never have been.
I think we're taking
Wait,
government.
that's AP calculus? Wait, it's all calculus? Oh, it has been.
That's what government is.
Wait, it's always a gin? Always has.
Okay.
Wait, Nate said? Always has.
Yes. Okay,
All right, can you do
Are
this?
you a winning son?
4.3.
Shit. I've been dead for 15 years.
So, do you want us to write? Oh, okay.
Yeah.
Write this statement.
Boy, I don't know.
Well,
Some of those are funny.
when the derivative of s is less, the graph f is increasing. When the derivative of f is negative, the graph of f is increasing.
You guys agree?
Wait,
I don't even agree.
what?
But is that like the choices? Like
So this is
positive,
AP
negative?
calculus?
Oh, wait, no,
Oh,
no,
it is?
positive, right?
No.
Yes.
Yeah, no, A is positive, right?
No one wants AP calculus. So the derivative of. Wait. Why not?
When the derivative of f
AP
is
calculus?
positive.
Sorry.
right.
Do you need to know this for a test?
Yes.
We do? Well, wait, we can usually use our
It's positive.
The derivative gives you the rate of change. So if the rate of change is positive, the graph is going up, right?
Yeah. So then opposite is negative.
Very good.
Yes.
Negative.
Concave upwards like that.
So it's this. Which means positive.
Would be positive. Right?
Yes, yes.
Yeah. What?
Opposite true.
Yeah.
No.
Yes.
What? What is C, D, E, F difference?
Wait, are C and D double?
get double.
Yeah,
derivative.
Yes.
they're at
Second derivative.
double prime.
So the opposite, right?
Stay the same.
No, it'd be opposite.
So it will be negative, and then concave outward, and then
No.
So I was positive.
and concave upward.
Yeah.
Our options,
Which one are we on?
it's,
Oh,
We're on E and F.
yeah, for E, my best guess is when F prime is negative, right, it's concave upward.
See, that was my first guess too, but he said it was wrong.
So it's gonna be positive.
So is it positive?
No, it's nothing, it's not negative or positive.
It's zero.
When it's zero,
It's infinite.
when it's
It's continuous.
not definable,
when it's changing in a particular way.
when it's what?
Changing in a particular way.
So what does that mean?
What? Huh?
What does that mean? This is no?
Think about it.
Bella,
It's infinite.
What'd you say?
Bella,
Bella, help.
Bella, we need your wisdom. The
What?
ghost of Bella.
Ah!
The ghost of
I
Bella.
can't see the questions. It just says presentation Ryan Sotelo.
Really?
Oh, no.
That's probably
Like I saw.
Hold on.
Wait a minute. Bella, we need your ghostly wisdom.
Are we on E?
Yeah.
Now can you
Do you
see?
now?
No.
No.
Really?
This is massive awesome.
Yeah, I see myself, and then I see you're presenting to everyone.
Oh, but now can you see this?
Okay, yeah, now I can see it.
Bella, what is your ghost? The ghost of Bella. What is your wisdom?
Wait, so far we have positive, negative, right?
Yes, yes.
What is your wisdom?
Okay.
Wait, give your advice.
Someone F?
You said
Okay, it went out again.
Oh, she said it went out.
It went out.
Yeah, like it'll go in and out.
Awkward.
Let me,
Ghostly wisdom.
Like maybe could you post it?
yes, yeah, I'm doing that now.
Okay. And then I can just pull it up.
Right.
So what is your wisdom on E?
I think she could see it before.
Topaz.
You guys are acting like I know more about this than you, and I wasn't even here Friday.
You're a
That's
ghost.
3 months.
Okay.
You have to
You
finish
said
your
it's-
task.
On the team.
Let's hear it.
Reactor's going on.
Yeah.
30 seconds.
What are we having?
I don't know.
Not Earl Grey.
I'll get more.
Stop crying about it.
So what are we?
Alright, you fix it after me.
I'm gonna grab tea bags for them.
It's not to me.
This guy, the answers are when it's either increasing or decreasing.
Oh, duh. So when it's
Someone
increasing,
should be there.
it's pointing upward. What's that?
When you're fixing electrical and you fix it and the doors close behind you, and then the imposter pops out of the vent. It is what it is. And then the other people do it is
I
what
need
it is.
spice.
I usually try
Sounds
to
interesting.
but sometimes
It's not only
It does,
sweet,
but-
but it's spicy.
You never know.
That's not the spicy mate.
I'm not either, but it sounds interesting.
Roasting.
It's so
It's so spicy.
And we should plug this in and then
Laser light is emitted.
It smells good.
avoid
We're just having this
exposure.
sweet-
Smell doesn't. Wait. What's all in it?
Wait, it's,
Well, it actually does smell good.
It's not apple. Yeah, but I don't normally like sweet and spicy stuff.
It does
I
smell
feel like it
good.
probably went into the kind of.
Oh, there's pineapple in it? Oh, bet.
Yeah, I smell that.
Okay, I guess we'll.
Oh my gosh, it smells crazy.
That way it's.
It kind of smells like chamomile or something.
Yeah, it smells good.
I don't actually like chamomile.
Ew, marble, no.
Oh, I love this cinnamon smelling.
Did you get that file, Bella?
Yes, yeah, I got it.
Well, now it's coffee. She said no coffee.
Oh, I don't
This is
know. I
coffee.
kind of sus it.
I'll let you know.
I don't think I trust it. I'm happy.
I'm
All right.
waiting for other people to taste it first before I go ahead.
Well, you can't see me draw them, Bella.
Why do you like no water?
Oh, can I
It
not?
smells like, oh my god.
Can you still not see me?
Rip, do you already have water? Marvel, do you already have water?
I can see that you're like I can see it now. I can see the worksheet.
Okay, I'm gonna try to draw something.
Okay, yeah, that's fine.
And
And if not, I can just go back and look at the recording or something.
Okay, yeah, that's true.
I don't need much to say.
Dude, it smells like straight up cinnamon.
I know.
Oh wait, oh, didn't you pour it out?
Yeah.
Oh yeah, that's why. Normally he's last.
I don't have a
Oh,
problem.
gosh.
Yeah, go ahead and use whatever.
Yeah, because normally I was like, wait, only like 2 people have gotten water. I'm like, how do we have this little left?
Marlon, come
But you
here.
got some.
Let me
Like, that
put
makes
it
so
in.
much more sense.
You're not doing this.
This smells like really good.
Yes.
Smells like straight up cinnamon.
I can smell from here.
Well, oh.
And we win.
All right. So here, I've drawn some curves. This is something with an upward acceleration on the left.
Come. Get in there. It's floating. Oh, it smells very, very strong.
These first two are things with positive accelerations.
Yeah.
So now the one on the left, if you look at it, it has a negative first derivative because it's decreasing, right? And then, so it's going down, right?
Yeah.
But it's accelerating upwards.
Wait, so the last two is positive and negative?
Increasing and decreasing.
Yeah.
Oh, and derivative is increasing?
Yeah, E is increasing and then F is decreasing.
So here's the function, right? And it is changing. It has a negative slope. Think of the little skateboard guy. So he has a steep negative slope. So that means the first derivative is negative in this range. But the rate at which the first derivative is changing it's negative, but it's becoming less and less negative all the time. Does that make sense? So if a negative number is getting closer to 0, it is increasing, right? Here, it becomes positive, and that keeps increasing as well. So when the first derivative is increasing, that means the second derivative is positive. Does that make sense?
Oh, yeah.
You can think of it like position, velocity, and acceleration. When the velocity is increasing, that means you have a positive acceleration. Why? Right?
There's a cute little quote on this.
Does it?
Yeah,
There is?
mine says, I destroy my enemy when I make them my friend. It
Oh.
went like,
Oh yeah, that's a good. I like that one.
Be a better person, make your enemies happy by giving them more reasons to hate you. Shaquille O'Neal?
Shaquille?
Or no, Shane O'Neal.
Oh,
Well, I just saw the S and I saw O'Neal. So I'm like, Shaquille? I'm like, this-
I got my quote. Ready? Over 300 years of experience established 76.
oh, right. 'cause
Oh,
you
Twining.
have stupid teeth.
Yeah, Twining's an old British company.
It is amazing what you can accomplish if you do not care who gets the credits.
Oh, wait, what was yours?
Mine
Keep
was,
it on.
I destroy my enemy when I make them my friend.
Can you make your what?
When I make them my friend.
Oh, that's some big.
That's actually a good one. I want to hear yours.
Honest 8.
Sunday is not a day of the week.
What?
That's not what it says.
Someday.
Oh, I thought you said Sunday.
No, no.
I was like, that's not
That's the worst quote.
This one
I was like, but it is.
Yeah.
Establish this, not hers.
Griffin, what's yours?
Never be the cause of someone else's bad day.
Aw.
Mr. Sotelo, you already got tea?
Yes.
I got tea.
Not Griffin, or not Marvel stealing.
This tastes pretty good.
It actually smells pretty good.
He always nice enough to just
I don't get that spicy part, but
Yummy.
I think Will should get the rest of the water, because Will's.
Good thing more
Yeah, his
water
mug
is
looks pretty empty.
Ooh, that is hot.
I'm scared.
That tastes good.
So are you guys okay on that?
Yeah.
Let's go on to the next
Wait,
one.
wait, I didn't write.
No, we
Sunday
got
is not a day of the week.
every
Yeah.
single
I
rock.
wrote that down.
Like, what did we decide for E and F?
Increasing and decreasing.
Okay,
Okay.
I didn't know what we put either, so I was gonna ask that. It's not just hot, Will. It's smoke.
All right, number 2 here.
Wait.
It's like ripping in that tie.
Oh, yeah. You're not just
Smoke.
You're smoking hot.
It's kind of scary though. All right,
So it's increasing.
What's that?
my phone.
No phones in class.
It's not out.
Yeah, no phones in class, guys.
Let's see.
Okay, 3x minus x cubed plus 5.
No
No
calculator.
calculator, this is ridiculous.
This is cap.
We're in calculus. We don't need the calculator.
Yeah,
Yeah,
it
we
literally
do.
says.
Wait, I didn't get to write it down. What was it?
That sucks.
I think it was 3x minus x cubed plus 5.
Okay. So first you want to rearrange that.
That's
Sure.
what I would have done.
You want your x cubed at the front.
That's what I would have done.
3x.
So we derive it once.
We'll take the first derivative. We probably want to take the second derivative, so we
Wait, I
might
don't
as
know what the
well.
questions were.
We'll go back to the questions after we take the derivatives.
Oof, that's awkward. I put one instead of that.
You can use y, that doesn't matter.
I know, but it makes me uncomfortable. Like, nah,
Is
I'm good.
negative
3x squared minus 3.
squared minus
Or negative 3x squared minus 3.
plus
Plus 3.
Plus 3.
Very
Why am
good.
I written?
I think it hurts.
Why am I written differently?
equals to negative 6x.
Nice.
All right. All right, so the questions were,
Good thing I wrote it at the bottom of this page and I have to put my questions on the next page.
So,
Yeah.
where is the function increasing?
What?
There's no way. I need
Excuse
to
me?
graph it.
This is illegal.
Well,
Left should be
hold
X.
up, I need.
Left should be X. Wait, it's negative. So it's
That to me.
concave. It's
That to
concave.
me, it's increasing.
Wait, the F prime is negative, so it's concave downward,
Wait, is this saying
right?
the graph
No, 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 no,
increasing
no.
or decreasing?
it's, where is it increasing? Isn't that what it said?
Increasing.
Yeah.
Increasing. It can't.
So it's gotta be up until,
Plus 3.
Well, let's think about
Plus
the,
three.
let's think about the first derivative of this function. I can factor out a 3, right?
Yeah.
In fact, I'm going to factor out a negative 3.
Just get x squared.
So x squared minus 1. Do I like, you know what? I don't even need to do that.
What? Which round?
All right, so let me just review something really quick with
This
you,
is
okay?
illegal.
You're hacking.
If I have a parabola, that the parent function is y is equal to x squared, right?
why?
Right?
Yes, that is a parabola.
That's the parent, that's the mother function or the parent function, right?
Yes.
That looks, that has a vertex,
You.
Yeah.
that has a vertex at 0, right?
Yep.
Yes.
0, 0. If I put a negative in front of the x squared, I flip it vertically,
But it's the highest point is still 0.
correct?
So it's fine, concave downward.
So it's 3.
What are you doing?
Whoa. Eli.
You forget
It smells
something?
like tea in here. Eli, we're
Yeah,
hacking.
Smells like cinnamon.
What?
What scared us?
Sex?
You scared yourself, man.
Oh, really?
Yeah.
Sounds scary, man, bro.
So if I make it negative x squared, it's reflected downward, right?
It's C for John.
Are you guys good?
So see your class.
I'm listening.
Wait, you.
I can't speak for the rest. I know Will's listening. And Griffin appears to be listening.
Right.
It's because I have a tie, I was here.
Right, so,
All right,
please do good.
if I make it negative 3x squared, what's that?
Then it's like expanded by 3,
It's a
because it's a
It's
horizontal
stretched by
stretch.
3. It's stretched
No.
by 3.
It's a vertical stretch?
vertical.
So So what does that mean?
Where is it? Oh.
Oh, so it'll shrink by.
It'll look like it narrows.
Yeah, no, I'm right, I'm right. It'll
Because
shrink by-
you're vertically stretching,
It's a spider,
which is the same as a horizontal
That's
compression.
6.
but it'll still be a spider.
But the vertex hasn't moved.
Yeah, so it'll be +5. Or
Now-
But
now-
the vertex will move.
No, yes, but if I say +3, it's only gonna move
Go, it
up.
moves up, that's
It'll
what I'm
move
saying.
up, but to get it to move left or
So
right,
it-
you have to look at the X.
Yeah, which we don't have any transformation. We have no horizontal shifts.
Right.
Is that okay?
So,
Are you following us at all, Bella?
So anything less than 0 is increasing.
you get it, Griffin?
Right?
Yeah, I understand the compressions and stretches and stuff. I'll just have to go back and look at the recording because I
Sure.
can't see the board.
So we're gonna have something kind of like this, right?
I didn't want that.
For
So
the
anything
first derivative. So that means the function has a positive,
Wait. But
Is it-
doesn't it ask when it's increasing?
+3.
yeah.
That is
Because it's not increasing on the right side.
compared down.
No, it's not asking when is the derivative increasing. They're asking when is the function increasing, f. So where f prime is positive.
I'm so lost.
Basically.
So this is just
I
negative
actually
3.
understand.
It's -3.
So you just have to graph it and then find where it's positive,
That's right.
like above the x-axis.
Yeah.
But when
It's high
okay,
up.
the question, what is the question exactly?
What is what?
What was the question then?
Is it a third?
When is the function
A
increasing?
third. No, it's just negative.
So I don't understand how when
Oh,
it's
I don't know.
positive, it's increasing instead of.
Is it 3
Because-
or is it?
Positive.
Okay, stop.
I think it's a third.
This is not the function. This is the function's derivative,
Right, but then,
Oh, we have to go back to
What
the
do you-
original.
which gives you the rate of change of the function.
So we have to go back to the regular original function.
Well, when the rate of change is positive, that means the original function is increasing,
Oh my goodness.
right?
Yeah.
Right?
Yeah.
Do you not get that?
Well, say that again. What did you say?
So this is the function f.
Yeah.
We're looking right now at f prime, the derivative, which gives you the rate of change of f. When the derivative is positive, that means the function f is increasing.
okay, so from the points on the X that are positive,
So it should be a -3rd and a third for x, right? Or is it 3?
they have to be the same, right? 'Cause
The
they're-
function is a cubic, so it's going to look
Oh.
like this. So you're going to have a range where the function is
Right, so it'd be like,
increasing.
for example, like a -3 to a 3.
What did we just?
What?
Or is it? I'm gonna wait. Can I?
That-
Yeah, it'll be
So it has to
symmetrical.
be the same point, just like.
Yeah,
Yes,
yeah.
yeah, it's a symmetrical,
Can
yeah.
I grab and see what it looks like? Or no?
Yeah, it's going to look just like this. Oh, the function itself? you mean?
Yeah.
Yeah, go ahead.
So what do you do then?
You just set this equal to 0, find where those points are, and then those are the.
Oh, no, I've not been.
So it's 1. Oh, it's 1.
No, I set the derivative equal to 0.
Solve it.
What's that?
Wait,
Yeah.
so would it end-
Divide by 3. It'll be 1. Square root of 1. Equals to positive -1. Woo! Woo!
So it's increasing from. Well, I shouldn't do hard bracket.
Yeah, exactly.
I should do.
That's it.
Yeah.
That makes sense.
Wait,
That's illegal.
okay, let me see what.
So from -1 to 1
Let me
is.
write this nice
Hold
stuff
your
down.
Well, I told him.
Are you following along, Bella?
Yeah.
So all we did was we took the derivative, we set that equal to 0, and found the zeros.
Okay.
And basically and when we did that, we got the answers were -1 and 1. And basically in between those numbers is when the function is increasing. So from
Okay.
-1 to 1.
So that would be the answer is that little shaded part.
Let me see the question.
Yeah, what was the question?
Where is the function increasing? That'll be from -1 to 1, in between -1
Okay.
and 1. Where is the function decreasing? in
I
interval.
mean, I guess.
It's just be
Wait, what do we?
anything left of -1 and anything.
Yeah, so you would say negative infinity to -1 union 1 to infinity.
It's gonna look like some domain stuff.
Right.
That's called interval notation.
Ew.
So when we were saying infinity, we were close.
So you could say when x is less than -1, and when x is greater than 1, or I should say or actually.
I accidentally started doing my infinity signs like Mrs. Rhodes does them,
Mm.
and it's making me super
How?
uncomfortable.
What? Like that?
Can I? No, I'm gonna do it real quick.
That's all.
Why do
I didn't
we
like
use
your-
Oh,
the function of
double O's?
-3?
That's
Yeah,
why.
she just goes.
Oh.
Oh, that's no.
I hate it, but I'm just doing it.
Sure.
I'm doing 2 zeros next to each other. So.
I just don't
Why
sign
do we
with
choose? Why did we choose -3x squared plus 3 to solve for the first question?
Because this represents the rate of change, and I wanted to find where it was 0, because that means that's where it goes from negative to positive, or from positive to negative.
Nah. What's a haircut? I've had 3 teachers tell me to shave, and that doesn't mean anything.
What's shape?
What's shaving?
It's kept up an illusion that it's not as long.
Are you guys okay? You could also write when the absolute value of x is greater than 1.
Never gonna be.
That's the same as all this. These are all equivalent. That make sense?
Yeah.
All right, the next question is, where is the function concave up? We're going to do the same thing, but we're going to do it with the second derivative now,
Okay. So
which
you
is
got
even easier.
y equals -6x.
Wait.
Why won't my thing?
And then you just have to graph -6x, which is so easy,
This is so dumb.
Uh-oh.
because it'll just be
Uh-oh.
-6.
My Windows is like falling apart.
No, wait.
Yes.
No, when it's decreasing, so it's the bottom. What? It's up.
Right, but we have to graph the second derivative
Is it like,
Wait, why?
minus increasing?
because
No, because we only have to use the first prime.
no.
Yeah, because it's decreasing.
It's increasing.
It's decreasing number, or 2b is worse.
F is decreasing.
I had a reason why we needed to graph the second one and I forgot it.
What is it?
That's for the next
Okay,
couple. That's for C and D.
That's what we're doing. We're doing C, aren't we?
Yes,
Wait, oh, we're doing C. Oh, then we're doing B.
Yes. Oh my god. I
we
knew
Oh.
just did B.
What?
Oh,
No, didn't we just do A?
no, we
No, we
just
just did B.
A was from -1 to 1. B
Yeah,
was
It's the
past.
outside of negative one.
Oh, that makes so much.
So now we have to graph the second derivative,
All
which
right.
is so easy.
Yeah, that's
It's
-6x?
-6x. So
Yeah.
just have a
Whoops,
nice little line. Tasty little line.
tasty. What's going on here? This is
Virus.
Oh no.
negative
Okay.
6x, right? Yeah, so
Yeah.
that's a steep line like so.
Yes.
So it's just to the left and right of 0, right? It's concave up to the left of 0, and it's concave down.
To the right.
So that means if we think about the graph, the function will be concave up. So it's going to be like, and then at -1, it's going to be increasing. And then at 0, it goes to concave down.
Isn't this one?
And then at 1, it'll be
So
going down.
this will be like the normal function. Or no? Wait.
Yeah, this is for f.
Right.
Yeah. This was f double prime.
Wait, do we always use the one before it? So if we do F double prime, we should be doing F prime because it's
Well, f prime was that downward.
Oh, okay. I don't know what I was thinking.
So we're looking to know when it's concave up and down.
Yeah, so this would be positive values of the double prime. These would be negative values. So for concave up, it's for, you could, in interval notation, you could do negative infinity to 0.
Ew.
And for
That's
concave
what I thought.
down, it'd be 0 to positive infinity.
Wait, would those be in union or no?
No.
No, those are separate questions.
Come on,
Oh, wait, there's
come on, Adrian.
questions. Is that D then?
Yeah, this would be
This is C and
this would be C and this would be
How do I
D.
use this?
Oh.
Is that okay, Bella? I know you can't see the drawing, but
Yeah, no, I'm just gonna have to go look at the recording later.
well, if you're not really following it, you can just, you don't have to stay on, I guess.
Okay.
It's up to you. All right, let's try the other ones.
Oh, no, not, oh, being gone again for lunch. That's sad.
All right, the points of inflection, those were, that was basically at 0.
Why?
The point of inflection is where the second derivative has a
That's where
0.
It crosses the,
Yeah, so that's where the concavity switched. It was concave up here,
so it's,
and then it
Right.
switches to concave down. So the inflection point is at 0.
right, that makes sense. Whenever it changes,
Whenever this second derivative crosses through 0.
right. So wait.
And then the F prime also crosses at 0. At 0.
Well, that crosses at 1 and negative 1.
Do you not put it on the sides then too? Like-
What?
Like for that top function?
This?
Yeah, or no. Like
This?
there's the one in the middle. I mean like that, no. Not, like this, right,
Mhm.
like this. Up. So we have that inflection point in the middle.
Yes.
But then don't you have the inflection points on the sides?
No, there's only one inflection point. That's at 0. So this is
Oh, I
always,
see it.
this is curving up, 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 curving down, curving down, curving down, curving down.
Oh,
Right?
yeah. Just this old graph looks weird now.
So when you look at F, function F,
Oh, but I see it.
What was the question
This
there?
goes straight with this one.
no.
All right.
This is a sad song.
That's the inflection points.
Oh, justify your response.
Find all extrema.
Oh, that's cake, bring me back. Alright. Your max and your min, like your
Uh-huh, yeah.
overall are
Uh-huh.
on either end.
Uh-huh,
They're gonna be the positive infinities and negative infinities.
uh-huh,
But you don't count those,
uh-huh, yeah.
Yeah.
so then it's just gonna be those 2
Yeah.
points.
What is
Yeah.
this local max, minimum?
Oops. Yeah, we look at the stationary points, right?
Yeah.
That's where the first derivative is 0.
Because that's 3.
So we have minus 1 and 1.
And why is that 3?
Yeah, we would plug it in to find the, they usually just want the x value,
Oh.
So just say negative 1 and 1.
but you could plug it into the function and find the y value.
It's not.
If we don't have to, then let's.
But looking from the second derivative, we can see that this was all concave up, positive second derivative, and negative second derivative. So because when it means concave up, what that means is when it has a turnaround, if you watch my hand here, it's going down, right? But when it switches, when it's concave up, when it reaches a stationary point where it goes flat, it's going to be going from downward to upward, right? Which means you have a minimum. So the sign on the second derivative is positive when you're at negative 1. So that means you have a minimum there. You know this is a minimum. And even if I didn't graph it, you would know it's a minimum because the second derivative is positive there. The second derivative is negative at 1. So that must be a spot where it was going up and then it turned around to go down. So that's a max. Easy?
Yeah.
Okay.
But we're not
We got
start-
4 minutes left.
yeah,
Oh, we got 4 minutes?
start anything new.
Yeah, we said.
Graph a sketch of the function using the information you have found.
We've been doing that,
I
right?
graphed that already.
We have been doing that. The one thing that is a little bit off with our graph is that
Absolutely.
we have the curvature, we have the turnaround points. This could be like anywhere. So we just have to find one point that we
Where it
know
starts.
and then pin the tail on the donkey, so to speak.
Oh,
Does that make sense?
What?
Pin the tail on the donkey.
Pin the tail of the graph.
Yeah, just plug in like 0. And then, so let's look at that function. I'm going to plug in 0, 5. You're going to be at 5.
Jeez. 5,
but none of them
5,
changed because we didn't deal with the Y value.
125.
Yeah, so we would go up to 5, and that's what our function would be.
So then if it was 3 before, it'd be 8.
No.
Yes,
No.
Oh, the Y value?
absolutely. Yeah,
Yeah.
because Will said it was 3,
What was 3?
that the values at Y were.
Oh, no, if he already plugged it in, then they would just get to, no, I don't know what he's talking about, actually.
Yeah, stop it, I'm right. I'm comfortable right now.
All right. We're going to have lunch soon, Bella.
Is she still on?
Oh, that's a train code.
Okay, that's fine. Just keep recording. I probably won't log back on. I'll just watch it later.
Okay.
Oh,
All right.
All right, thank you.
Yes, sorry.
That's a
That.
bomb.
Have a good day. She's behind you, by the way.
Yeah, I know.
She's off now. That's kind of funny. Let me figure out where.
Oh, here's the flex.
What's the top?
Waldo.
Woo!
Oh wait, I went too far. That's not bad. You can pretty much see the whole room.
When I was watching a recording of it, what happened?
Anything for Will?
I'm doing the top. Over.
Yes.
Until the end.
Lunch. 44.
All right, Sloppy Joe.
Um,
When's Joe gonna clean up his act?
Yeah, when's Joe gonna?
Who's Joe?
Oh! Joe!
This is kind of good.
Well, no, this tea is really good.
It's not my favorite, it's okay.
It's not your favorite? It's
No, I
I
give
taste the
it-
cinnamon.
I mean Earl Grey.
yeah, I mean, obviously you're right, but it's pretty good.
It's not even spicy.
I also liked
It's
that
just-
peach one or 2 days ago. That was really good. Whoa, let's see first.
What? Your next date?
Get like a private jet.
Should we ask Coach K your secret constantly? That's why I put money on
Yeah, well,
When there's no one there,
Yes. Always.
the smell.
This is
you're
gonna
messing
be
with
so
the
bad.
man with the tie.
Well,
huh?
it smells glorious.
Glorious.
All right. One more thing to learn.
Are you winning, son?
It's still recording.
So snazzy without a tie.
Wait, did you wear that?
No, maybe he can take it off. He just like put it back on when he got in here.
In comes a marvel from the Griffin.
Huh.
We're recording that whole time.
Oh, it's gonna be a huge,
What's his high kick?
That's not gonna be that fun.
Okay, don't tell me I'll be that Griffin.
That was Marvel.
I know. I just saw you out of the corner of my
Yeah,
eye.
I can tell how you can tell to do it.
Not bad.
Wait, what? What'd you just do?
I'm practicing my high kicks. I want to be able to stand with my leg up.
Ah, that looks like it hurts.
No, you know how people like do that though? Like they just have their leg like
Yeah, and then
straight
they're
like
just
that.
like, woo.
Like, that's not.
That's like impossible for a guy.
You just hear like this crack.
Just
Like,
moonwalk.
Like,
Moonwalk.
oh.
Do a video.
Sprawl over and over.
Do a video. We gotta learn how to moonwalk in this class.
Like, I got
that's like the final.
That's our final. Is that
That's our
we can
final.
moonwalk?
You guys were gonna do a song.
Well, then we gotta practice the moonwalk in that. That's
Oh,
why we
yeah,
need it.
that's fair.
Nate,
Griffin's ready
look at this.
for anything.
Guys, we're gonna be dressing up, and we're gonna be like,
You know, it's kind of it's gonna be hard to talk to Bella.
oh, that was
Like,
Oh, yeah, watch this.
You know what's funny?
What?
I was in my mom made me do taekwondo when I was a kid.
Oh, she told us about
I
that.
think your high kicks are so high.
What's that?
Show us a high kick.
No, the last time I tried that.
Okay,
I hurt
good.
myself.
It's kind of wind. It's kind of windy. Not gonna lie.
Yes.
kinda.
Yeah.
Quick.
Yeah. What did she tell you?
I was an assistant
just
black
that,
belt for
you
taekwondo.
and, like, she had the kids do taekwondo and everything, and like she learned it. She said one time she used it on a man at church when
Oh,
they were-
Mrs.
Church?
Yeah.
a homeless guy walked in. He like went to pull something out, and she thought it was gonna be a knife or a gun, and she said she noticed he had like a bad leg. He was limping, so she went for that leg and kicked him down, and then he pulled out like a little like religious book or something. That she called that.
Oh my
She
god.
just wanted to like pray with him or something. Like, she attacked him.
She's like, I'm so sorry. I thought you were like, kind of.
And then he pulls out the gun like, oh, now I know.
She made us do the, and you have to have these key.
Adrian, you good?
I want to do it again.
You good,
Just
buddy?
disappear on the screen.
Yeah, now there's gonna be recorded. You just.
Oh my god.
Just disappear on the screen.
Yeah. whoosh,
I landed
Just
really
hair.
well.
just like the hair.
Yeah, but Bella can't see you land. She's just gonna
Bro, I
see
know too.
You have to do like these key ups, which is like when you do like a strike, you yell or you do some sort of scream. So me and my friends, to just protest being there, we did moo. So like the whole time we were just mooing. And then one time I did try to do like a roundhouse kick, and like
you. Oh, I cannot do those.
I did that so fast that like I picked myself up, like I went off my
And then you start flying
foot,
away like a helicopter.
and then I landed on my foot like this, and it like really hurt my foot. I'm just like, I quit.
Like, I'm done.
Yeah,
This is so we can no longer arm from the line.
I never got past white belt.
Oh, how are we not finishing putting one cup? That's embarrassing.
Oh my, are you cereal?
Yeah, I got distracted.
Cereal?
All right, guys, I've got
Get away, baby.
another thing to teach you.
Oh gosh dang it. We were in school?
This one.
Dag nabbit.
Wait,
Good.
wait, we're in school?
Yes.
Wait, is it recess?
Wait, this isn't St. Mary's recess? In the
Close
field?
that. That's cold. What are you doing, Raoul?
son?
All right. So
I am winning, son.
here's a circle.
Circle. That's not a circle.
That's a circle. That's a triangle.
What's the
Wait a minute.
Three.
center?
Okay.
Three.
No.
I don't know. I just know.
If
X plus Y.
they
equals
have
three.
to both.
What's the center?
What's the center?
Wait, what's the circle?
What?
What is the
Zero.
circle?
It's zero.
0.
Yes.
Just 0.
What is
Because
it?
9 is your radius.
Yeah, I know.
I've decided.
You are incorrect.
3 is 3.
3 is the radius.
3 is the radius.
Okay, fine. What?
Radius squared.
Okay. Okay. So
Where's the
is
center?
radius. I've decided.
Okay.
Hold on.
But there's nothing
Let me
else
grab it.
indicating a movement. So it's at 0.
0, 0. Yeah.
Yes.
Yes.
Oh my.
The center is at the origin, right?
How do we find out center though?
What's that?
How do
It
we find out
doesn't
center?
say like plus.
Yeah, if there's no one.
Yeah, it's
Right.
Oh, really use your brain.
Yeah, well,
I've been trying.
Well, you've been trying, so have we.
so if you have
I
translation,
didn't write that down.
What? Write that down. Write that down.
that would be centered at HK,
Amazing.
right?
Write that down. Zers. Write that down.
Oh, just minus x minus h
Wait, no,
squared.
no, go back.
I'll just tell it to you.
Oh,
Ready?
Too far back.
Ready?
No.
no.
Parentheses
I don't think I
X.
can.
No, upgrade.
There you go. There you go. There you go.
Oh,
It's back.
I could have read that to you.
From
By name.
memory.
You're so troublesome.
But
Y is
minus k
center.
angles.
So this would be centered at HK.
Radius.
Oh my god, yes, this is great. Oh my god, wait, I remember when you did this in computers. Stop. I remember in computers when you showed us how you like draw faces.
Yeah.
Wait, what?
Did we do that?
Wait,
Yeah,
That's fun.
wow.
he does a circle and then the line for like the face and then a little nose which is just squiggly.
What?
What is this? That's him drawing a frontward face. A little blush.
But then you get rid of the circle, right?
Yeah.
Well, yeah.
No, you just keep the circle. Get rid of it.
What?
Oh my goodness.
Isn't that a handsome young lad?
No.
Hey,
Why is his eye squinted?
Because he's Asian.
he's normal.
That
Is there something wrong with that?
Give him little dots. Make those his eyebrows. Give him little
Actually,
dot
I think
dots.
about me. Doesn't that
These?
side one kind of?
No. Give him little dots on both of the blush. Yes. Yes. He looks so much better now.
Like what? What did he
The
just
No,
side angle
no,
is
they're eyebrows.
shaggy. It's
Like
shaggy.
what are eyebrows?
Like skins. Like skins.
Oh.
Okay.
I like that one more.
What's that? What's that?
That's
Coach K
pretty.
just,
That's
Coach
pretty.
K just looked at us
That's
like, like,
pretty.
Coach K was just like, yeah, Coach K looked at me and was like,
Okay.
like skins.
Stop.
That's L.
Okay.
Like skins.
I keep
All right. You guys ready? I'm just gonna start over.
I just broke my wrist.
Can't do anything.
One.
I can't write any notebook.
No.
Good thing there's a recording. Good thing there's a recording.
Oh.
Oh. Gross.
Oh.
Oh, what
All right, you guys ready?
Someone sabotaged the recording.
All right, you
That
guys,
button.
this is
Tom's
called
in it down.
implicit differentiation.
Thumbs are
This
down.
is implicit?
Yeah,
With circles?
anything.
Well, what have we done?
When you accidentally sabotage the OSHU instead of reactivating it, that's failed successful.
All right, so what's the derivative of x squared?
That's failed successful.
2x.
2x.
Yeah.
What?
Now, what's the derivative of y? Do you remember this?
Yeah, kind of.
No.
You're gonna
Oh.
you're
you
gonna
have to make
take
it-
2
Do
y.
what?
Yeah. Now times the derivative of y.
2.
So you think of y as a function of x. So you'll do the power rule, but then you have to sort of do the derivative of what's inside, like the chain rule.
Right, but there's nothing.
So still-
inside
Well,
of
y is some function of x.
So you just put x.
So you'll just put y prime.
Oh.
What?
I kind of remember this.
I don't remember this at
And
all.
then equal to
Derivative of 9.
nothing. 0.
It's 0.
Good.
Wait, I don't remember this at all. When did we learn this?
All
Like,
Right now.
literally forever. Just the
Never?
one. And we didn't
Wait,
really
never.
talk about it. So we're learning it right now.
What?
When
Okay.
you have y, you have to apply the chain rule, and the function of y is just y.
All right. I can get rid of the 2's. Don't need them, right?
You do be canceling.
It's our.
You got x plus y Y prime. equals 0.
That good?
Yes. Wait,
Wow.
no.
Wait.
Oh, okay. You're one step ahead of me.
And then.
Ooh,
Yeah.
a little equal sign.
Yeah.
Whoa.
Wait
this-
a minute.
Whoa.
Is this so that you have your relative x over y? Nice.
Well, this can work for like any equation. So,
Oh,
so you can have an equation, and this is just how you can take a derivative.
So the y prime is negative, oh, wait. Negative x over y, yeah?
Which part? Is this true for everything?
Yeah.
So once we have that bottom thing,
So you can take derivatives. X,
Oh,
x, you don't have to worry.
Come back, you got the door.
Owen.
Sam,
that was
Damn!
awesome.
Sammy.
Awkward.
did he not look?
He's so funny. I always say hi to him in the halls, and he always goes, so.
Sophomore. Wait, he's a sophomore.
He is.
Two.
It took me a little while to get used to that.
Oh.
Ever since we kind of missed, like,
Yeah.
Half of the square.
yeah.
A quarter of the school year.
Like I saw them, I'm like, oh, the freshmen are back. I was like, oh, they're not freshmen. anymore.
Wait, he's a sophomore.
Yes,
You're
sir.
a captain.
He's a big grown boy.
He's the homecoming.
He's the president.
Is he?
He's what?
Oh, yeah, you're right,
President
yeah.
of the company.
Of his
I
class.
have no idea.
Yeah, he's the
No,
homecoming.
Penny's the president. So.
Homecoming
Is he?
freshman.
Oh yeah, he was the.
Yeah, I think you're right.
Attendant. Oh, yeah.
Oh,
Who's the person?
I was sophomore year.
All right.
congratulations, Nick.
What's an equation you guys know from
Kind
science?
of a big deal, huh?
What'd you ask?
What's an equation you guys know from science?
From science.
Science?
I'll give you one.
Y equals half
Y equals
of
negative
G.
half of G delta
Y?
G squared.
Why do we need to do this?
I don't know. No, delta T.
We don't need delta T. I always ditch it.
Delta!
I always ditch it.
No delta, no
Yeah,
equation.
You don't need it.
I
I
need
get
delta.
If you take your initial time to be 0,
I'm disgusted by the fact that there's not a delta.
all right. I'll start again.
Did you just erase the whole thing? Well, actually, I guess you don't need the negative half if your G is negative 9.81.
What's that?
Like if you plug in negative 9.81.
Just take the negative
then
sign
you can
away.
take the negative out of the half.
Yeah,
Oh,
take the
Because
negative
sure.
away.
she puts it in there in case you forget about the negative, but I would never forget about a
It's
negative.
always negative 9.81.
I remember as negative 9.8.
Yeah, so you can ditch that, yeah, that little loser.
Well,
G should be positive, but that's okay.
G is not positive,
It's gravity.
Yeah.
Should be,
which is negative.
depends.
Well, yeah. I mean,
Physics is lying. The world is alive. My head's about to explode.
Yeah, I mean,
Physics.
when you can prove 0 is 1, yeah, that's a lie.
You can prove what?
That's when you know we're in a
I didn't
simulation.
prove that.
I don't know, I was watching a video yesterday.
you divide by 0,
Wow.
basically.
Oh,
You're like, oh my god.
Close the window. Why? I'm freezing.
Marvel,
Marvel, Waldo is freezing.
this isn't about you, it's about Mr. Sotelo.
Mr. Stella, just because he looks like Waldo, doesn't mean we don't know where he is.
That's Waldo.
He has the same
He's
shirt.
very like bright and maroon.
Yeah.
Where's Waldo?
Waldo's like bright.
Yeah, that's like painfully bright red and white.
Well, the shirt's now a little
Also, he's
old,
not
isn't
wearing
it?
a hat.
The shirt's,
Oh,
the shirt's a little
Yeah, you
old.
don't
isn't
wear
it?
a hat inside, do you, Adrian?
well, Waldo does.
No, Waldo's
No,
white.
that's Waldo.
Waldo always wears a hat inside.
Waldo's
Cap.
white.
That is not.
That's Cap.
No, it's
This
not.
is not wearing one right now.
That's not Waldo.
Yeah, these.
How about
We have
how about
a-
a how about a different equation? Because that one
We have you best.
will be
How
easy.
many of your middle name was actually Waldo?
Equation.
Ryan Waldo
X.
Sotelo.
But we have her.
Well, from science.
X equals V of X.
V.
Yeah.
B
No, sorry. V sub X.
T.
Delta T.
T.
Distance equals rate times time.
Yes.
Uh,
Do you not like this one either, Mr. Sotelo?
No,
Maybe give us some more
Because you're
specification.
doing time ones. That so.
Okay, so then we won't do a time one. But I'm out of.
X over delta T equals V. Boom.
You got
Okay.
delta T.
Fine, then we just
I'll
remove the delta and make it.
I'll pull up a kinematic equation for you.
No, because those all involve T.
No, one of
I
them.
want
doesn't.
on T.
Yes, they do.
One
That's
of them
cap.
doesn't, I don't think.
There is a professor of physics.
Yes.
No, there is no heat.
No time. Or no.
There's.
We're running.
They all
out of
have T in
time.
them.
You know what? Pick your own equation. I give you options and one options, and you don't want any of them.
You gave him 2.
I gave him 6 because I offered all the kinematic
You mean
equations.
Waldo?
and he said no.
You mean Waldo?
I said him.
Yeah, Waldo.
Waldo is a him, is he not?
Don't do things.
Just do
no,
an
it's
equation
you.
from AP Bio, that one equation.
One that doesn't have time, like one that's.
What's the equation for AP Bio?
Yeah, Marvel.
I don't know.
Then I don't know either.
How do you guys not know any equations? Have you taken chemistry or
Yeah, like forever ago.
Yeah, chemistry was a sophomore year.
physical science?
Chemistry was a junior type of thing.
Yeah, that's chem too.
Exactly.
I'm saying chem.
Yeah, that was.
Ideal gas law.
Honors chem was
Ever use that?
Oh. Gee, that-
I guess what would you guys
Okay,
know?
wait, no. PV equals NRT.
There you go.
That's T. That's temperature.
That's temperature.
Yeah, that's not.
I just heard T and I went off, but
Kelvin.
you're welcome.
That is
Ideal gas law.
in chemistry. Yeah.
The R is 0.0821.
What's that?
The R is a constant, which is 0.0821,
Is it?
Then why is it there?
because it's what R is.
So why don't you just put 0.8 to 1 there?
So that's a constant.
0.0821.
Yeah.
Because you don't want to write that out. You
I'm
use-
very clear for them.
It's like when you write pi instead of pi.
Why
What do you
would
got?
A smoothie.
So what do you want to do with this?
A
Uh,
smoothie.
let me think if this is a good one.
Oh, what are you playing?
How would I take the derivative
Oh, you wouldn't.
of the left of the left?
If we don't say.
So yeah, think of these as
It'd be 0.
two functions.
So if you have f prime,
Wait,
Like-
f prime, is that
Yeah. How do I find the derivative of two functions multiplied.
Then you take f
What do we
s
use?
prime times f prime.
Well, like when we had this.
How do you take the derivative? Oh, okay, your multiplication rule. So
Yeah.
g prime times h, or yeah, g prime times h prime times g. Or yeah,
Yeah.
well, it's not times.
Wait, what do you guys think?
Why are you talking to Antonio?
He's not in this contract.
Heavy.
We can't.
It's embarrassing.
Oh, dude. So what's next?
So what would the derivative of the left side be?
Wait, I wrote this wrong. So then you got, I got you. You have p prime,
Good.
v,
Yeah.
v plus
Yeah.
v prime p.
Good. Now on the right, R is a constant.
VIP.
Sure. R is a constant, right?
Yes.
So just don't worry about that. We'll just have R.
Factor out.
Yeah, we'll factor that out. Now it's n times t, right?
Yeah. N times t.
So that goes the same way.
And oops.
What?
Illegal.
What's
What is
that?
this illegalness?
An L?
Why is
10.
this?
Oh my god. VIP and 10. Wait, no, you wrote it wrong.
Okay.
Why is this
Alright.
illegal?
It's not. Next. Oh my god, next.
Knit.
Two.
You're not learning what I want you to learn.
Does this remote turn the TV on?
No,
Whoa.
that's a mouse.
No, Griffin.
Dang it.
Turn it back on.
What the?
Yes. It's a mouse and a keyboard. It's an air mouse.
Wait, what?
What?
Can you like move the cursor?
If it's plugged in, yeah, you can aim it and
What?
Wait a
So
minute.
it's like
You got
a
plugged
one.
in.
That's
Wait.
literally a one.
Wait. How?
You're telling me you've had magic this whole time?
He is.
You're telling me you're.
I'm the
He's
magic
Harry
bean.
Potter, that's why.
You're telling me you're
magic
Waldo the
bean,
magician?
right. The magic bean's wand, that's just that remote. He just walks around and enters math equations on the TV.
I have.
No.
Gordon has had.
So you're telling me all this time you could have been doing magic on the screen?
I also have a touch.
Stop!
Wait, what is that? Does that do that
That's
too?
a touchpad!
But does it do that?
It can if I got it plugged into that computer. This computer's the one that's running it now.
Are we using the magic thing?
I don't know that it will work that well.
He's Perry.
Harry the heck?
He's Perry.
It's for like on the couch and the computer has a TV.
Uh-huh.
You can be like, I'm sorry.
He's
Why is that like the coolest thing?
Oh my god, that should be our math.
What?
Never mind.
Agent P theme instead, but with calculus.
Why, cross?
Let me see if I can find.
It's a
Agent D.
agent
C.
Implicit. Oh no, I don't want the video.
D.
Okay, so 3.7.
He's a big math term that people use on the low.
No.
Searching for
He's got a beaver
one
tail
of us
and a bill.
is an owl. Who? That's the thing, we don't.
All right, here you go.
Uh-uh.
Yes, huh?
Wait, I can't see. Can you zoom in? We got X,
What?
2, Y, plus X, Y, 2,
Equals.
Are you doing it?
6. So
Wait.
my
This is illegal
problem is,
again.
I don't have a problem. I like take a little derivative. Gonna end up with, actually,
No, she's lost.
no, I'm definitely
Well,
not.
I'm lost.
I'm just lost because there's an extra variable. Like before we just said X squared, Y squared.
So
But I don't know. if
this
you
is
divide-
what do we call?
Oh, you have to do chain rule with the Y again.
Yes, yes.
Okay, so you have 2X
2x times
times
y.
Y prime.
Now
No?
this is a product rule. So derivative of the first times
Oh,
the
you
second
2x times
Okay.
y plus xy squared, right?
times x squared y prime.
Yeah.
I remember.
Wait, you leave the Y.
Wait, why?
Okay,
Why?
right.
I took the derivative of y and I got y
Oh.
prime.
If it were y squared, then you'd have y and y prime.
Then would
Yes,
it be
yeah, yeah.
that?
So that's what you'll do for the next one.
Yes, yeah. So
Look
the
at me.
derivative
X.
first,
So now you got y squared.
Y squared
X.
Y prime. Or Y.
X or
Wait,
Y
you
squared.
just get rid of the x because right.
derivative of x is 1.
Right. So then you have y1 or y prime. X y.
Y.
X y prime
Equals,
equals 6.
try again.
Zero.
0, yeah, derivatives.
But you have to get rid of the 6 first, right?
We took derivatives
Yeah,
of everything.
The right.
Oh, duh.
The right.
All right, so I've got two terms with y prime. I'm going to factor the y prime out. And then I've got these terms. And that equals 0. Easy?
is that the answer?
Almost. We just need to find y prime.
So bring it all over.
Hold on.
Yeah, move that over to the other side.
Over.
So you'll
Over
move everything,
this.
yeah, and then you'll.
There you go. That's how y varies with x in
Okay, that
this
makes sense.
in this equation.
Wait, is that G or Y?
Okay.
Y.
There's no G.
Yeah, g pops
You
in.
silly.
And then you introduce gravity.
Right.
Then gravity has entered the.
And then you introduce the speed of light in there as well.
Wait, the speed of light isn't already in there?
Where'd your tie? Oh, there's your tie.
What?
I was gonna be like, "Where's your tie, Griffin?" And then I found it.
Well, it's actually my time. It's actually our.
It's actually
That's
our.
It's
Is
actually.
he?
My turn with the tie.
No.
No.
It's your turn.
Your-
Our
No,
turn.
Is that good?
Our turn for ours.
All right, let's clean the desk.
Look at
No,
that.
you're not good. We're good.
All right, hopefully Bella enjoys.
No, not Bella enjoys. We enjoy.